Now we have one more very important formula, that is x raised to n minus a raised to n divided by x minus a, which is equal to n a raised to n minus 1, right? So hence you have this particular formula. Say for example, x raised to 7 minus a raised to 7 upon x minus a would turn out to be 7a raised to 7 minus 1, that is 7a raised to 6. There may be situation where you will have different powers in the numerator and denominator, and as a result of which we may have to divide both numerator and denominator by a. So the rule that you have to take care that both the terms x and a will be a constant, have to be raised to the same power. Now let us see how we can apply this formula. For example, you have 1 minus x raised to minus 1 by 3. So we have 1 minus x raised to minus 1 by 3 divided by 1 minus x raised to minus 2 by 3 as x tends. So now this can be written as minus of x raised to minus 1 by 3 minus 1 upon minus of x raised to minus 2 by 3 minus, we can write as minus 1 raised to 1 by 3 minus 1 raised to minus 2 by 3. 1 is written as like this. So this gets cancelled as x tends to 1. So this is of the form x raised to n minus a raised to n. This is x raised to n. But we don't have the x minus a term. So we divide both numerator and denominator by x minus 1. So x raised to minus 1 by 3 minus minus 1 raised to minus 1 by 3 divided by x minus 1 upon x raised to minus 2 by 3 minus 1 raised to minus 2 by 3 upon x minus 1. We need to find the limit of this. We can write this limit as x tends to 1. Remember the examples that we did till now, all of them contain limit as x tends to 0 or x tends to infinity. But here x has to tend to a, that is 1. Now this will turn out to be n. N in this case is minus 1 by 3 into a, that is 1. N minus 1, minus 1 by 3 minus 1. Upon denominator, you have n is minus 2 by 3 into 1 raised to minus 2 by 3 minus 1. This eventually is nothing but 1. So it's eventually minus 1 by 3 into minus 3 by 2, which will turn out to be half into, this of course is 1, both these are 1 each. So you get half as the right option. Yes, we do have it that way. Furthermore, x square minus root x divided by root x minus 1. X square as x tends to 1. So we have x square minus root x. So it is, so we have this particular case, we have x square minus root x upon root x minus 1 as x tends to 1. So now, if you see here we have x square minus root x, and we can write it as, we can take out root x common, and hence you get x raised to 3 by 2 minus 1, which is nothing but minus 1 raised to 3 by 2 upon x raised to half minus 1 raised to half, which is going to be root x, then divide both numerator and denominator by x minus 1, x raised to half minus 1 raised to half divided by x minus 1. And now you take the limit. This is nothing but limit as x tends to 1 of root x into limit as x tends to 1 of x raised to 3 by 2 minus 1 raised to 3 by 2 upon x minus 1 divided by limit as x tends to 1 x raised to half minus half upon x minus 1. limit as x tends to 1, this part is going to be root 1 into n in the first case is 3 by 2 into a, that is 1 raised to 3 by 2 minus 1 divided by half into 1 raised to half minus 1. This will be root 1, which is 1 into 3 by 2 into 1 raised to anything is 1, 3 by 2 divided by half, which will be 3 by 2 into 2 by 1, which will turn out to be 3. Hence, our correct answer is 3 here. Right. Yes, we do get it as 3. Okay, now we have 1 plus x raised to 6 minus 1 upon x plus 1 square minus 1. Then limit of so and so is equal to what? Okay, there are two ways of doing this. One is we can do by simplification process. The other one is we can do by the formula. So if you see, this is nothing but 1 plus x raised to 6 minus 1 divided by 1 plus x square minus 1. Now it is told x tends to 0. We can use the formula. We can write it as 1 raised to 6. We can write this as 1 square. Now as x tends to 0, add 1 to both sides, you get x plus 1. So will tend to 1. So this alone, this x plus 1 is tending to 1. So we are actually using the same formula. Now you can divide both numerator and denominator by x, which is nothing but x plus 1 minus 1, which is the same as x, upon 1 plus x square minus 1 square upon x plus 1 minus 1. Now this now is the limit. So you need to do limit as x plus 1 tends to 1. This is nothing but n, that is 6a, that is 1 raised to 6 minus 1 divided by denominator. You have 2 into 1 into 2 minus 1, which will turn out to be 6 into 1 raised to 5 upon 2, which will turn out to be 3. Or you can use the formula that 1 plus x raised to n minus 1 raised to n upon x is equal to n itself. So it's going to be 6 itself, and this is going to be 2. So 6 by 2, which will turn out to be 3. So 6 by 2, that is 3, which is option number this. Let's check our answer tallies. Yes, it is true. So what do we have here? You have x plus 2 raised to 5 by 3 minus p plus 2 raised to 5 by 3 upon x minus p. Now if you see, this is of the form x raised to n and this is the form a raised to n, but the denominator does not have x plus 2 and p plus 2. So what we do is we add 2 and also subtract 2. So, and also as x tends to p, add 2 to both sides, x plus 2 will tend to p plus 2. So the same limit will written as limit of this as x plus 2 tends to p plus 2. Now this can be now written as x plus 2 the whole raised to 5 by 2 minus p plus 2 the whole raised to 5 by 2, this is 5 by 2, upon x plus 2 minus p plus 2. So now, and this is limit as x plus 2 tends to p plus 2. So this is of the form x raised to n minus a raised to n upon x minus a as x tends to a. So this is now going to be n, which is 5 by 2, into a, which is p plus 2, raised to n minus 1, 5 by 2 minus 1, which will turn out to be 5 by 2 into p plus 2 raised to 3 by 2. So this should be the final answer. Let's check among these. You don't have any of these working, so this will be, it's none of these, because the answer is 5 by 2 into p plus 2 raised to 3 by 2. Right. Alright, so it is none of these. Okay. Next, we have is x raised to 3 by 2 minus 2 raised to 3 by 4 divided by root x minus 2 raised to 1 by 4. If you see, this one will be written as x raised to 3 by 2. 2 can be written as, it can be written as minus 2. X raised to 2 by 2 raised to 3 by 4. And here you can write this as minus root 2 raised to 3 by 2. 2 can be written as root 2 and hence root 2 raised to 3 by 2 and divided by root x, that is x raised to half. Again this can be written as root 2 raised to half, because 2 raised to 1 by 4 is nothing but 2 raised to half into half, which is the same as root 2 raised to half, which is the same in this case. It is 2 raised to half into 3 by 2, hence root 2. Now here this will form x raised to n minus a raised to n, but this is another thing. So what we need to do is we can divide by x minus root 2. X raised to 3 by 2 minus root 2 raised to 3 by 2 upon root 2 divided by x raised to half minus root 2 raised to half upon root 2. So this is of the form x raised to n minus a raised to n upon x minus, you are dividing by x minus root 2, x minus root 2, and hence we end up getting NA. So it's going to be n is 3 by 2 into a is root 2, NA raised to root n minus 1 divided by half into root 2 raised to half minus 1, and hence we get this as 3 by 2 into root 2 raised to 3 by 2 minus 1 is half divided by half into root 2 raised to minus half. This 2 gets cancelled, so you get 3 into root 2 plus half. Taking this a raised to n divided by a raised to n is a raised to n plus n, which will be 3 root 2 raised to 1, which will be eventually 3 root 2. So hence what we have done in this case is, again we are divided by x minus a. So x minus a, and of course the new concept over here, since this is 2n, we need to keep this power the same as this, which is very important. Same way here it is root x, so it's x raised to half. Even this has to be kept the same power. It has to be something raised to half. So both these are written as numbers raised to 3 by 2 and half respectively. So hence accordingly we use this and we get half into root 2 raised to half minus 1. This should be, of course, which will turn out to be root 2 raised to minus half. So this on simplification gives you 3 root 2. So, which is option number C. So do we get that? Yes, we do have it. Furthermore on this, we have if x raised to n minus 3 raised to n, that is limit of x raised to n minus 3 raised to n upon x minus 3 as x tends to 3 is 1, 0, 8. Then find the value of this. In that case, it's going to be n, that is n, into a, that is 3 raised to n minus 1 is 108. So you have to find out the value of n which will satisfy this equation. So we can definitely factorize 108. 108 would be and this is 3 cube. So basically n into 3 n minus 1 is 4 into 3 cube. So that means n is going to be 4 and n minus 1 is 3. So n would be 408 is nothing but 4 into 3 cube. That means n into 3 raised to n minus 1 is also 4 into 3 cube. So compare n with 4 and n minus 1 with 3. Both ways you end up getting n as 4. So n will turn out to be 4 among these. Right. Okay, we get that as 4. Quite similar to this, you have x raised to n minus 2 raised to n upon x minus 2. Limit as x tends to 2. This turns out to be 80, which means a in this case is 2 raised to n minus 1 is 80. So we need to again factorize 80. 80 can be written as 5 into 16, which is 5 into 2 raised to 4. So n into 2 raised to n minus 1 is 5 into 2 raised to 4. So that means n is 5, n minus 1 is 4. So n has to be 5. So n will be 5 in this case. Right. We have it that way. Okay. Now, quite similar to this, you have a sum over here. X raised to 5 by 2. So this can be written as x raised to 5 by 2. And this 2 raised to 5 by 4, as I told yesterday earlier, it's 2 raised to 5 by 2 is 2 raised to half into 5 by 2, which is the same as root 2 raised to 5 by 2. The idea is that the power of x and the power of the other constant should be the same. So this can be written as root 2 raised to 5 by 2 divided by root x, that is x raised to half. Much the same way, this can be written as root 2 raised to half, because 2 raised to 1 by 4 is the same as root 2 raised to half. Now you can divide by x minus root 2. So we get x raised to 5 by 2 minus root 2 raised to 5 by 2 divided by x minus root 2. Minus root 2 raised to half, divided by x minus root 2. So this is actually root 2 raised to half. So now, this is going to be this limit and this limit. So this will turn out to be n in the numerator is 5 by 2, a is root 2 raised to n minus 1, that is 5 by 2 minus 1. Divide for the denominator, it's n. N again in this case is going to be half into root 2 raised to half minus 1. So this gets cancelled, of course. 5 into root 2 raised to 3 by 2 upon root 2 raised to minus half, which will turn out to be 5 into root 2 raised to 3 by 2 plus half, which will be 5 into root 2 raised to 3 plus 1, 4 by 2, that is 5 into root 2 square, which is 5 into 2, which is 10. So the value of this expression of this particular limit is 10. So in all these, you're dividing by x minus a format. Right, and hence we get it as 10. Okay, now here we have a particular situation. So we have x plus x squared plus x cubed plus x raised to n minus n, the whole divided by x minus 1. So this is like telling you have minus 1. So minus n itself is, so you can split up this minus n as minus 1, minus 1, minus 1, minus 1. And hence you can write it as x minus 1 plus x squared minus 1 plus x cubed minus 1 plus x raised to n minus 1 and so on, plus x4 minus 1 plus x raised to n minus 1. And of course can be written as square, 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 square. divided by x minus 1, x minus 1, x minus 1, x minus 1, so and so x minus 1. Now this, if you use limit of this as x tends to 1, is NA. In this case, for example, 1, 1, A, that is into 1 raised to 0, which is going to be 1. Then N2 into 1 raised to 2 minus 1, 1, plus N in this case is 3 into 1 raised to 3 minus 1, 2. This would be 4 into 1 raised to 3, and so on and so forth. The last one would be N into 1 raised to N minus 1, which is ultimately equal to 1 plus 2 plus 3 plus 4 plus N. That is sum of the first n natural numbers, which will be N into N plus 1 upon 2. So the limit of this is N into N plus 1 upon 2, if you see the formula of this itself. So ultimately it is B, which is the answer here. Yes, we do get it that way. Okay, this was similar to one of the questions we did earlier. So we here have the same thing, that here if you see x is actually x plus 2 and a is c plus 2. So as x tends to c, add 2 to both sides, you have x plus 2 tending to c plus 2. So the same expression, this will be written as x plus 2 raised to 3 by 2 minus c plus 2 raised to 3 by 2 upon, this can be written as x plus 2 minus c plus 2 as limit as x plus 2 tends to c plus 2. So this is of the form x raised to n minus a raised to n upon x minus a is equal to na, that is 3 by 2 into a, that is c plus 2 raised to n minus 1, 3 by 2 minus 1, which will turn out to be 3 by 2 into 3 by 2 minus 1, that is half, that is root c plus 2. And hence among these, this is the right answer. That is 3 by 2 root c plus 2. Right, that's how we get it. Okay, furthermore, we have one more very important 3-Moser formulae which we use. Log 1 plus x, which we did earlier also, the whole upon s as x tends to 0 is log e to the base e, which is 1. Log 1 plus x to the base a by x as x tends to 0 is log e to the base a. Please don't mix it up with log a to the base e. That was log a to the base e of the earlier was a raised to x minus 1 upon x. Here it is log of 1 plus x. So as an offshoot of this, if you look at x tending to 0, it is equivalent to telling x as 1 by x tends to infinity. So in that case, if x tends to infinity, the same x, this 1 by x, you can convert this to 1 by x and this will be 1 by x and you get log e to the base e. So both these are one and the same. Right. Okay. Let's take up this one. Log 1 plus px upon e raised to 3x minus 1. So what do we do? In the numerator, we multiply both numerator of the numerator and the denominator by px. And here you multiply by 3x and e raised to 3x minus 1 upon 3x. Now why do we do that? So that it caters to the particular formula, log 1 plus px upon px, which will turn out to be px into log e. This will all be 3x into log e. This gets cancelled, of course. Log e is nothing but 1. So p by 3 into 1 by 1, which is p upon 3. So there is option number A. So it's p by 3 is the answer. So basically you multiplied into which the same exercise we had done in the previous questions too. Yes, we do get it as p by 3. We have a situation here. We have log 1 minus x by 2 upon x, limit as x tends to 0. Now first thing that is there is we need minus x by 2. Whatever 1 is subtracted from in the numerator, whatever is subtracted from 1, the same thing you need to be putting over here. So you need to multiply, so it will turn out to be minus x. So you need to divide by log 1 minus x by 2. You need to multiply and divide by minus 2. So that we get minus x by 2. So this can be now written as minus half into log 1 minus x by 2 upon minus x by 2. Whatever you take 1 minus x by 2, hence you need minus x by 2. And since there was only x and from x you got minus x by 2, you have to also multiply by minus half. This will turn out to be minus half into log e to the base e, which will be just minus half into 1, which is minus half. Hence we get it as minus half. Okay, we get that as minus half. Okay. Next is x upon log 1 plus x. So you can divide both numerator and denominator by x. So you get x by x. And denominator you have log of 1 plus x, the whole upon x. And this is limit as x tends to 0. This will be eventually 1 upon log 1 plus x to the base x will be log e, which is 1. So 1 by 1, which is 1. So the correct answer in this case is 1 itself. We have it that way. Yes, we do get it. Further. Okay. So here we have limit as x tends to 0, 6x plus 8x e raised to x divided by log 1 plus 2x. So we have 6x plus 8x e raised to x divided by log 1 plus 2x. So you can divide both, take out numerator and denominator, you can take out 2x common or divide by 2x. So you get 6x by 2x is 3 plus 4e raised to x, and this will become log 1 plus 2x divided by 2x. So it is 3 plus 4e raised to x. Since you're dividing both numerators, 6x by 2x is 3, 8x by 2x is 4, e raised to x. Now we need to find limit as x tends to 0 of this. So this turns out to be 3 plus 4 e raised to 1. Since this is determinate quantity, you can straight away substitute e raised to 1. And log 1 plus 2x upon 2x is again log e, and this turns out to be 3 plus 4 e raised to 0. I'm sorry, this should be e raised to 0. So this will be 3 plus 4 into 1 upon 1, which is 3 plus 4, which is 7. So that will turn out to be 7. And the right answer is 7. Okay.